This is the first of several videos where I'm going to walk you through the entire break packet, and we're going to go through each problem step by step. Now, of course, I'm giving you the answers, but that's not the point. The point is that a lot of this is, this actually is one problem for every single learning target we've learned this year. So it's going to be super helpful as we move forward into our review part of the year, because we have one more brand new unit after this on statistics. And then after that, we're reviewing everything so that we can make sure you have a solid background for next year. Now, fortunately for us, the Regents have been canceled. And so if you pass the class, you pass the Regents. So for that reason, more than ever, it's important that you pass my Algebra 2 class, because then you automatically pass one of the hardest Regents tests there is out there. So super excited about that news. That's good news for all of us. But I want you to listen as we go through these, because if you do, it'll help you when we get into that review section to make sure that you do pass the class and that you are able to get credit for both the class and the Regents. And then you'll be much more prepared for next year, whether you've had the geometry class yet or not. Either direction you go, this will help prepare you. So super excited about how we're going to be able to move forward this year, not having to worry about the Regents and just having to worry about you actually understanding math for the sake of understanding it and passing the class. So for number one, the learning target is I can simplify and evaluate expressions. So it starts off with, we're evaluating this equation right here. So we're just going to use order of operations and go backwards. So they're adding 6. So we're going to subtract 6 from both sides. So when we do, that brings us over to here, where we have 3 times x minus 7 divided by 2 equal 9, because 15 minus 6 is 9. And then because we're dividing by 2, we're going to multiply both sides by 2. When we do that, they cancel here. And then over here, we're going to distribute the 3. Remember, when you have a number in front of parentheses, you distribute. This becomes 3x minus 21 equal, and over here, 9 times 2 is 18. Now we're to a basic two-step equation, which goes back to Algebra 1. So we know that they're subtracting 21, so we're going to add 21. And then that gives us 3x equal 39. Now we're multiplying by 3, so we're going to do the opposite. We're going to divide by 3, and that leaves us x equal 13. So for the first learning target, what we mainly focused on was reviewing Algebra 1 concepts and specifically order of operations. All right, so the next question is number 2, and it is the learning target, I can multiply polynomials. Now, this is the FOIL or box method. So, but we made it a little more challenging, because instead of Algebra 1, where you had just 2, we actually have 3 that you're going to multiply together. So this is not bad if you take it step by step. So we're going to take the first 2, x plus 4 times x minus 1, so just these first 2 right here, and we're going to go ahead and FOIL that. Remember, FOIL is just a fancy way to say distribute. So you're going to distribute the x, and then you're going to distribute the 4. So x times x is x squared. X times negative 1 is negative x. Then it's time to distribute the 4. 4 times x is 4x. 4 times negative 1 is negative 4. Finally, we combine our like terms, and we get x squared. Negative x plus 4x is 3x minus 4. So we combined our like terms there. Now we would be done if we only had those 2, but we have a third over here, this 3x plus 7, that we still have to multiply by this whole thing. Now it looks longer, but it's the same exact process. And in fact, I rewrote it by changing and putting this part in the front, because I like to distribute 2 into 3 rather than 3 into 2. I just find it easier. It works either way. All right, so let's distribute. So we're going to first distribute the 3. 3x times x squared is 3x to the third. Remember, when you multiply exponents, you add them. Then 3x times 3x is 9x squared. And then 3x times negative 4 is negative 12x. Now we're going to go through and distribute the 7. 7 times x squared is 7x squared. 7 times 3x is 21x. And 7 times negative 4 is negative 28. Now, that's a lot of terms. So what we're going to do now is we're going to go through and we're going to combine them. Now, you remember from way back earlier in class this year that if you had me, and I think Alex does the same thing and so does Matt, we tend to underline or mark what we're combining. Just makes it easy so that you don't leave anything out on accident. So there's only one term with an x cubed, and that's 3x to the third power, so we just copy it down. But then you can see that I've underlined these two twice because those are the two terms that have an x squared. Remember, we always start with our highest exponent and work our way down. So that means that we have 9 plus 7, which is 16x squared. Then we combine these. So I put squiggly lines under them because they're like terms. Negative 12 plus 21 is actually 9x. And then finally, we just have this 28 left over, negative 28. So that is our final answer when we're trying to express a product in standard form. Remember, standard form means all of them in a row from highest exponent to no variable at all. Number 3, I can identify and define functions. And I know I feel like I'm going kind of fast, but I didn't want to bore you by making it too long. And I know that you can hit rewind and watch it again if you need to. So now we're talking about functions. We're going to identify domain and range. Remember, domain are your x values. So you're looking at left to right. Range are the y values. So that's low to high, the bottom to the top. So let's look at our picture here. And you can see I put a little dotted line box around from the lowest point down here to the highest point, that's our range, and from as far left as it goes to the farthest right that it goes, and that's our domain. So we want to deal with domain first. So the domain is that we are going to do, this goes backwards to negative 1. Now it's a closed in dot. So remember, closed in means that it's equal to the negative 1, not just greater than. So it's greater than or equal to negative 1. And then as we go all the way to this side, our farthest to the right point is 1, 2, 3, 4. So our domain goes from negative 1 to positive 4. And there are two different ways we learn to express that, right? So when we look at it, you can see that the domain can be written this way. This is called interval notation. Remember, if it's not included, had those been open dots, then that would have been parentheses. But remember, closed dot means it is included, so it's a bracket. So negative 1 to 4. Or you can write it this way. Negative 1 is less than or equal to x is less than or equal to 4. So that works. Or this is set notation where we write the brackets and we say x, and that line just, it looks like an absolute value line, and it represents such that. So x, such that, you're defining it. Negative 1 is less than or equal to x is less than or equal to 4. Both of these are acceptable. If you remember, I prefer this way, but that is a complete personal choice. You can do either method. And even this method where you just write it without the set notation and define it. All right, so the next thing we're going to do is the range. Okay, so the range, that's the low. So let's count. We have negative 1, 2, 3, 4, 5, 6, 7. And then this goes to here, but look, it rounds up even higher. Excuse me. So we have to talk about the very highest point. Well, the highest point is way at the top of that curve. It's not down here where it ends. So that is actually, if we count all the way up there, that's 9. So the lowest point is negative 7, and that highest point in that curve is actually 9. So our range then is bracket negative 7, comma 9, close the brackets. Again, they're both included, nothing's open. Or you can write it this way, negative 7 is less than or equal to y, which is less than or equal to 9. Or you can write it in set notation where you have the little bracket that says y such that negative 7 is less than or equal to y is less than or equal to 9. All right, and then this one is evaluating functions. We're going to roll up a little bit here. We're evaluating functions. And so a lot of you will remember this once we just kind of refresh your memory a little bit. Here's g of x and here's h of x. Those are two different functions. I want to know what is g of h of 3. So I have to go in and plug 3 into h first. So I do the inside first. I plug 3 into the h function. And then when I get that answer, I take the answer and I plug it into g. So we're going to start with h and we're going to put a 3 where the x is. So over here, we have h of 3. Well, h of 3 is 7 times x, but x is now 3, minus 11. So then you just solve. 7 times 3 is 21, and 21 minus 11 is 10. So h of 3 is equal to 10. Now, if h of 3 is 10, we want g of 10. So then we're going to take g of 10. So we're going to go to the g formula, the g function. And so instead of x, we're going to put 10 squared minus 5. So we just plug the 10 into that equation. And then now 10 squared is 10 times 10, which is 100. 100 minus 5 is 95. And that is how you do the first 4. Okay? We're going to stop there for the first one, and we'll pick up with the next video starting with number 5. See you soon.